Hi everyone, in this video, let's discuss Kubernetes. This is a short video, so let's try to understand Kubernetes in 10 minutes. Before we start discussing Kubernetes, let's try to understand container first. What is a container? Okay, a container basically a software package. It's nothing but a software package. That means we are packaging the application into a container, and this container you can see here in this image. This container contains the application code, configuration, environment details, the binaries and libraries required to run the application, and the runtime details. So all these parameters required, all these dependencies required to run the application, together with the application code, we are bundling into a container. That's what the container. We are bundling together. That's what container. So you can understand this as a basic concept of container. That means when we say a container, that's nothing but a software package which contains application code as well as its all dependent binaries, libraries, and the configurations. Okay. Now just look at this image. This image shows a difference between virtual machines and containers, right? Virtual machines is basically nothing but we have a physical server. On top of the physical server, there is a hypervisor running in the physical server, and on top of this, we will be creating virtual machines. So each virtual machines will be having a guest operating system, means a operating system, right? Each virtual machine is isolated system, and each will have an operating system. And then if let's say there is an application running in this VM, we can run only one application in this VM, because this application will be using the binaries and libraries of this VM. Okay, this is the virtual machine. Now let's compare this with the container. So this containers is being created on top of the virtual machine or a server. So we have a server or virtual machine. In that server, we have operating system. On top of the operating system, we create multiple containers. A container will contain application and all its binaries and libraries and other components we saw in the previous slides. So here you can see in the one operating system, on top of one operating system, we can run multiple containers. That means we can run multiple applications independently. So all these are isolated systems. So we can, on top of one operating system, we can run multiple applications without, they're not interfering each other. But when it comes to the virtual machine here, as the application will be having dependency with the binaries and libraries of operating systems, we can run only one application here. So you can think virtual machines or a normal server, it is a virtualization over hardware. Right? We have a hardware because that's a physical server. Then we created virtualization on top of hardware that became VM. Now container, it's nothing but a virtualization over operating system, right? Virtualization over operating system. That's what container is. Now, why we need container? Okay? Why we need container? Let's take one example. Let's say we developed an application in our development environment, right? This is a server, right? VM or server. We created an application here, and we did initial testing. We completed initial testing, and we want to move this to, let's say, pre-prod. Okay, this is pre-prod VM. Now, if you want to move this application which we developed in the dev server to pre-prod server, there's a lot of work because you have to move the application code. Not only application code, there would be a lot of dependent libraries, binaries, which you have in this VM. You have to move it separately, right? So this moving is very difficult in the previous scenario, which is where we have application in the server or a virtual machine. That's where container comes into the place. So since we are bundling application code and all its dependencies together in this container, we can easily move this, right? This container have all code, libraries, everything. We can easily move from anywhere. Like even if this present in the dev environment, if you want to move this application to a pre-prod, we can simply move this. We can simply deploy this container in the pre-prod. We don't need to worry about dependencies or packages or libraries. We don't need to worry about anything. We can just wrap it and move it anywhere. That's the number one reason why we need container. Okay. Now since we understood the containers, let's try to understand Kubernetes. What is Kubernetes? Kubernetes, it's actually an open source platform. Okay. It's an open source platform to deploy and manage containers, right? So in a production environment, in a big production environment, there would be many hundreds of containers, right? There would be many containers for one single application itself. So to manage and deploy, it's not easy to manage individual containers. So that's why we need a platform such as Kubernetes to manage these containers. Right? It's not about just managing containers in Kubernetes. Kubernetes is capable of doing more. Like Kubernetes can do, for example, something for like scale up. Right? We can scale up. Like if application, like say we have application running in a Kubernetes, and if application is getting more load, right? Just like how we have in a cloud, the Kubernetes can create a replica of that application and distribute that traffic. And then handle the failover. Means if let's say if a container failed, if container is failed, the Kubernetes can spin off a new container instantly and avoid or make a minimal impact or avoid much impact from the failure. Right? So it can handle a failover as well. And then load balance the traffic, which I mentioned earlier. So it can create a replica of a same container, multiple replica of a same container, and distribute the traffic into multiple containers. So basically by doing that, we will able to reduce the load from single container, and customer and users will get much better performance or better experience with the performance ways. Okay. That's what Kubernetes. Now let's see this one picture, right? This is what currently happening. Transition to Kubernetes. So initially we have a monolithic application. So let's imagine we have a monolithic application, nothing but we have one big application called recruitment website. This has many components: job application, job vacancies, recruiters, right? It has many components. This was as a monolithic application. It's all components are a part of a single application, a single service. Now this being transitioned into microservices. So we have an application, but each components of the application became separate services. Separate service. So basically, recruiter became one service, job application became another service, job vacancies became another service. So one monolithic application converted into multiple small services, microservices. Now we started to deploy these microservices in the container. Docker is nothing but a container runtime, right? So we started to deploy these microservices into a container, right? Now we have a container. Now we need to manage this container. So we started to deploy these containers in the Kubernetes, right? This is the transition currently happening in the industry. All right. Now let's try to understand few components of Kubernetes or few important keywords of Kubernetes, right? First, pod and node. So this is a little bit deeper about Kubernetes. Again, I'm not going too much inside because we don't have that much time in this video, but I will explain few important components of Kubernetes that you need to understand the overall overview of Kubernetes, or overall you need to get overall understanding of Kubernetes. What is node? A node, so the first one is a node. What is a node? A node is nothing but a server where you have installed your Kubernetes, right? A node is nothing but a server where you have installed Kubernetes. So this is node. Okay, this is node. Now, on this node, we have Kubernetes installed. This is where all the function is happening in the Kubernetes. For example, like a traffic is coming, container is being deployed, or application is being deployed. Everything is in this server, which is known as a node. Now on this server, we have a pod, right? What is pod? Pod is the smallest unit in the Kubernetes. This is where our containers will be sitting. A pod can contain one or more container. Right? A pod can have one or more containers, but you can understand like this. This is where we deploy our application, right? Because where is our application? Our application is in the container, right? Our application is in the container and we deploy this container in this pod. So pod is the place where we have our application. Okay, one server will have many pods, right? This is what node and pod. Now, what is service and ingress? Okay, so now let's say we have one application that's been deployed in a pod, right? Now we have three replica of the same application, right? This is app1, app1, app1. So all three pods are the same application. We have created multiple like replica for the load balancing purpose, right? To manage the load. So how do we manage the load in the Kubernetes? So there is a concept called service. So there is a service will be sitting in front of these pods, and the service will distribute the traffic to the backend port. So service is much like a load balancer in our classic networking terms. It's much like a load balancer. So traffic comes from the outside, it hits services, and then it redistribute the traffic to either of the pod as per its load balancer algorithm. Okay, this is service. Now, what is ingress? Ingress, it's somewhat similar to service, but what is the difference between service and ingress? Ingress can do layer 7 routing. And what is the backend of ingress is a service. Backend of service was pods, but backend of ingress is a service. So we have service 1, service 2, okay, and a ingress. Okay, so ingress will route the traffic to the services based on the layer 7, layer 7 rules. So for example, if a traffic is coming to /my_time, it will route to SVC2. If traffic is coming to /my_job, it will route to the service 1. So basically, it's like layer 7 load balancer, L7. Layer 7 load balancer. It's a layer 7 load balancer. It can do routing based on the URI, based on the layer 7 header. Now, in the backend of service, you will have again ports, right? These ports, right? You will have again these ports. So this is how the traffic flow happens. Now, before we end, like this is like our last topic, the Kubernetes cluster architecture, right? Again, I'm not going to talk about all the components here, all the components of the control plane and everything in detail, but just to give summary, I will talk about architecture here. So when we talk about a Kubernetes cluster, a cluster will have at least two or more servers or nodes. This is node, right? And in this, one node will be a master node, other node will be worker node. Okay, master node and worker node. These two terms you need to understand: master node and worker node. Now, what is worker node? What is master node? Master node is nothing but a control plane. Okay, this is where you have a control plane is running. This is where the control plane, the master node is the one who is taking all the decision, that's the one who is like creating the pods, right? But that's what master node. But where these pods are being created, these pods are being created in the worker nodes, right? Here we have a pods being created in the worker node. So the actual application traffic will be coming into the worker node and then going into the application, right? So all the work is done by worker node, but all the instruction is giving by the master node. So master node have a lot of other process like etcd or API server. All these processes required to run the Kubernetes and control this entire cluster. I'm not going into details in this video, but you can understand this way. There's a two type of node: master node, worker node. Master node is control plane, worker node is a data plane, and where all our pods and applications being deployed in the worker node, and our application traffic will be coming to the worker node. All right, that's all in this video. I hope you guys followed and understood what is understand a summary of Kubernetes. And if you like this video, please subscribe to this channel. We'll see you with another video.